Hello, I'm Mike Walker. Welcome to a demonstration on how to find performance information in an SMI-S 1.8.0 array. This demo is shown as a quick start guide for array performance on my GitHub site for SMI-S mocks, and identified in a video on installation and setup for running mockups of SMI-S WebM servers. The Quick Start Guide is a 13-page document that highlights information that can be found in about 70 pages of the SMI-S. The block server performance profile of the block book in SMI-S. In this script, we'll be working with pywbem 1.1.1 and version 080 of pywbemtools, which is where we will get the pywbem CLI that we will be using. So let's begin. We'll switch to my command prompt window. First, we'll go to our virtual environments where I have my mockups. So we do work on mocks. And we are in our virtual environment called mocks. And mocks are actually in the DEV directory. So the first thing we need to do is to connect to our mock for an SMI-S 1.8 array. And when I connect to it, I'll point out items that were introduced after 161. So we'll first establish the connection to the array mock. And we'll do that with a pywbem CLI command that's going to drop us into command mode using the CLI. And we're going to ask for output in a default output in table format. And we're connecting to the array mock. And we have successfully connected. Having done that, we're ready to start issuing our commands. Now, in SMI-S 1.8, advanced metrics was defined for storage arrays. We can determine if our mock array supports this by inspecting the SIM block statistics capabilities. Specifically, the supported features will include the value of 6 if they're supported. So let's get the performance capabilities, and we will do this in a couple of requests, starting with the supported features. So we're going to do an instance enumerate on block statistics capabilities, asking for instance ID and supported features. And we see it has 2 supported features. One is client-defined sequence, and I'll explain that later. But it also has the value 6 for advanced metrics. So our mock array does indeed support advanced metrics. So the next thing we want to know is what elements are statistics kept for. And that's done with this command, enumerate instance of SIM block statistics capabilities, again with the instance ID and asking for element types supported. Okay, so here we see it's going to keep, the system will keep statistics on computer system, front-end ports, volume, and disk drives. Next, we'll see what other capabilities are supported. And the first we're going to look at is what methods are supported. By this array, and we do that with an instance enumerate on the capabilities, asking for instance ID and synchronous methods supported. And we see there are 4 methods that are supported. Get statistics collection, that's going to be an important one. Manifest creation, manifest modification, and manifest removal. And I'll explain what a manifest is later. We want to focus right now on the statistics, but we'll get to manifests a little later on in the demo. So the next request is again on block statistics capabilities, and this time we're going to look for the clock tick interval. And I'll explain what that is when we get there. So this says the clock tick interval is 100,000, and this tells us it's in microseconds. So the clock tick interval is 100,000 microseconds. Now, why is that important? Time in the statistics is kept in counters, and the counters aren't seconds, they're clock tick intervals. So when you see a time counter, you're looking at the number of 100,000 microseconds. So that's an important piece of data we need to keep in mind as we look at statistics. Next, we'll look at what the block statistics capabilities are related to. And to do that, we're going to look at an instance shrub command. We're going to do it in MOF format. We're asking for an instance shrub on the capabilities. Now, a shrub will tell us everything that the statistics is directly related to. So let's see what the statistics or capabilities are directly related to. So it tells us the capabilities are the capabilities role and an element capabilities going to a managed element, which happens to be a block statistics service, which has the name block statistics service. And that's the only association of the block statistics capabilities. So the next thing we need to do is look at the service and see what the service can tell us. And for this, we'll do enumerate on block statistics service. So we're enumerating sim block statistics service, asking for a property list of name, enabled default, enabled state, requested state, and started. And we see the enabled default is enabled, the enabled state is enabled, the requested state is not applicable, which means you can't change the state. It can only change on its own. And it started is true. In terms of finding statistics, there are a couple of approaches you could take. You could start with an element for which statistics are kept, but a more straightforward approach is to find the statistics collection. This collects all the statistics for all the element types. So let's find the statistics collection with the following command. It's another enumerate, but in this enumerate, we're going to ask for the data in MOF format because it shows up better than the table format. And we see the statistics collection has an element name, a statistics collection, and an instance ID, but it also has sample interval, and this is in date time format. What this is telling us is the sample time interval is 15 minutes, and it tells us the last time statistics were collected. So the next thing is we want to know something about the statistics collection, specifically what's it related to, because one of the things we're going to want to know is what it collects. So again, we're asking this in MA format, and we're asking for an instance shrub, and we're going to go for all the associations off the collection. And because there's only one collection, we don't have to select which one we want. And there are a number of associations. So the collection has a statistics role in an associated block statistics manifest collection to a manifest collection, which is the block statistics manifest collection. And this appears to be the default block statistics manifest collection. And I will get to discussing manifest collections, but we'll ignore that for now. We also see that the statistics collection is hosted on a computer system, and the computer system is, in fact, our array computer system. And finally, it collects members following a member collection association. And there are 12 statistical data records. And we see there's 1 for the array, there are 8 for disk drives, there's 2 for front-end ports, and there's a record for storage volumes. Now, the block statistical data is where the actual statistics are kept. And there's 1 for each of these different elements. So we'll start by looking at statistical data, and we'll look at 1 instance of each element type, starting with the array. To illustrate what the advanced metrics offers, I will run 2 requests for each element type. The first command will retrieve the basic statistics that everybody has to support, and the second will retrieve the advanced statistics. For the array, the command to retrieve basic statistics is as follows. We're going to do an instance get on block storage statistical data, and we'll get the instance type and element type. And the only thing kept in basic statistics are total IOs and kbytes transferred. Now, I know this because I know what the spec says. So we're doing this for the array, so we'll select item 0, and we get the array, and it is an element type 2 computer system. The total IO count is 132, and the kbytes transferred is 66. Notice it's units, so it's kbytes transferred. So that's what you get if an array only supports the basic statistics. Now we're going to look at what you get if you have an array or are working with an array that supports advanced statistics. Now, these are in addition to the total IOs and kbytes transferred. You also get read IOs, read hit IOs, kbytes read, write IOs, write hit IOs, and kbytes written. And we're talking the array. And so we see the read IOs are 132, the read hit IOs are a much larger number. Kbytes written are 66, or kbytes read are 66, or write IOs are 0, write hit IOs, and kbytes written. So you get quite a few more statistics in the advanced statistics for array. Now, the next one we're going to look at is Frontend Ports. And I'm going to get the basic statistics for front-end ports. Get instance block storage statistics, getting instance ID and element type, total IOs and kbytes transferred. Again, the basic statistics are fairly nominal. Now here's our front-end port. So select 9. And we see we did in fact get a front-end port record. Total IOs were 66. The kbytes transferred were 33. So the next item is going to show you what you get what additional things you get if the array supports advanced metrics. So we'll get the instance ID and element type, and the only thing added is an IO time counter. And again, we're selecting 9. And the IO time counter is 935,579. Notice there's no units on this. There's no way to say this is the number of clock tick intervals, but this is a time counter, and this is where the clock tick interval comes into play. So the next thing we're going to look at is storage volumes, and we're going to retrieve the basic counter or basic statistics for a storage volume. And this is fairly healthy. We'll get the instance ID and element type, but we have total IOs, kbytes transferred, read IOs, and write IOs. And we want storage volume, which is item 11. And we see that it is, in fact, a record for storage volume. Total IOs were 132. The kbytes transferred were 66. The read IOs were 132, and there were no write IOs. So that was the basic statistics. So now we're going to look at what you get with the advanced statistics, or what additional things you get with advanced statistics for storage volumes. We do an instance get, instance ID and element type. We'll get an IO time counter in addition, and we'll get kbytes read and kbytes written. And again, we're working with the volume. So we select 11. And we see the IO time counter, 152,996 clock tick intervals. Kbytes written or kbytes, and kbytes read are 66, and kbytes written are 0. So we do get quite a bit more information for the volumes when we're supporting the advanced metrics. So the last element type we need to look at are disk drives. So let's look at the basic information required for disk drives. So we're going to get the instance ID, element type, total IOs, kbytes transferred, and read IOs. And let's see, if we pick item 1, we'll get a disk drive. And sure enough, we got a disk drive. total IOs were quite healthy. That's a large number. And k bytes written is a rather large number. And the read IOs are equally large number, almost equally a large number. So that's the basic statistics for a disk drive. And when you add the statistics for the advanced metrics, there's quite a few. IO time counter, k bytes written, or read, k bytes read, write IOs, k bytes written, and an idle time counter. Now, just to be clear, actually in advanced metrics, it calls for either the IO time counter or the idle time counter. You don't have to provide both. So let's see what we've got in our mock array. And we were looking at this drive, the first disk drive. And we see both the IO time counter and the idle time counter are provided. Now, that wasn't required, but it's okay if you do it. and we did it in this mock array. There's a bunch of k bytes written, a bunch of write IOs, k bytes read, I'm sorry, write IOs and k bytes written, and we have the time counters, and it looks like there's a lot more idle time than there is IO time. Now, the other thing you need to understand is on the time counters, we're talking cumulative elapsed time in clock tick interval units in the time interval you're working with. Finally, we get down to explaining the manifest and manifest collection. We've been waiting a long time to hear what this is. So the sim block statistics manifest collection associated with the statistics collection, if you recall the shrub command earlier on, the statistics collection contains manifests for each of the element types. There's one manifest for each of the element types. Now, there's important information in these manifests, so let's look at the manifests. And we'll do an instance shrub on the manifest collection, and this time we're going to restrict the request to the members of the collection. And we see this is a manifest collection called manifest default. It's the collection, and it has members, and the member of collection goes to the members, and there are 4 members. There's a statistics manifest for default for the array, there's one for disks, and there's one for front-end ports and one for volumes. So here there's basically a default manifest for each collection. Well, let's look at one to illustrate what a manifest is. We don't have to look at them all. And we'll do that with we'll do that in MOF format, because as you'll see, a manifest is a rather large thing. And let's look at the manifest for the array. And this is going to be multiple screens. Let me scroll up to the top. So we have the default manifest for the array. The element type is 2. Now there's a bunch of include properties. Many include properties. These are Booleans. If it says include start statistics time equal false, means that statistics is not kept. But include statistics time says that is kept. And so you see total hours, k bytes transferred are true, etc., etc. And that's going to tell you, you can look at the manifest to tell you what is in, what statistics are going to be kept for the element type in question. Now the next thing we want to look at in this manifest is CSV sequence. This is if you're dumping the data out into a CSV file. This is the order you want the labels and the properties in that file. And there's a default manifest, and that's what the system will give you. But if you were defining your own client-defined manifest, and if you go back to our capabilities, the ability to create your own client-defined manifest was one of the capabilities that we supposedly have with this mock. So you can define the only sequence or the sequence of values that you yourself want. So that's a manifest, and that completes our review of the 1.8 block performance information, and where you can find what elements are being monitored and whether or not you have the advanced metrics in the array that you're talking to.